Exercise 1.7. Which is the only even prime number? First of all, we need to have the understanding about a prime number. A prime number is a number having one and itself as a divisor. Means only two divisors. One and itself. So any number that won't be a prime number, that is called a composite number. That means having at least three divisors, namely one itself and any other number. So that would be a composite number. Okay. Which is the only even prime number? Since we know that the set of prime number, it starts from 2, 3, 5, 7, and so on. So the smallest and the only even prime number is 2. So the answer to this is the only even prime number is 2. Okay. How many odd prime numbers are there that are less than 50? Odd prime numbers that are less than 50. So we can count them out. Uh, 3, 5, 7, not 9, it is 11, 13, then 17, 19. 21 is not a prime number since it is divisible by 7 as well as 3. 23 is a prime number. 25 is not because it is divisible by 5. 27 is not a prime number since it is divisible by 3 and 9 as well. 31 is a prime number. 33 is not because 33 is divisible by 3 as well as 11. Then 35, it is also a composite number because 35 is divisible by 5 as well as 7. So 35 is a composite number, it's not a prime number. Then 37, 39 is not a prime number since we can divide 39 by 3. So 41, 43, and as far as 45 is concerned, 45, it is divisible by 5. It is divisible by 9 as well. So that is not a prime number. So uh, because 45 is a composite number. So as far as uh, this thing is concerned, 47, that is also a prime number and as well as an odd number. But 49 is not a prime number because 49 is divisible by 7. 7 sevens are 49. So that's it. How many prime numbers are there that are less than 50? So these are the numbers, the prime numbers which are odd, lesser than 50. So we can count them. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13. So we can say this is it. Uh, I guess I'm missing out something. 3, 5, 7, 11, 13, 17, 19. Then 21 is not 23. Then 25, 27 are not. Yes, 29 was missing. So yes. So now counting them up, we get that these are 14 numbers which are odd prime numbers. Okay. So that's it. Question number 2. Question number 3 now. List the composite numbers greater than 4 but less than 30. So composite numbers, 5 is not a composite number, so we won't write it down. 6 is a composite number because it is divisible by 2 as well as 3. 7 is not a composite number, it is a prime number. Then 8, it is a composite number divisible by 2 and 4. 9 is not a prime number, it is a composite number, it is divisible by 3. Then 10, then 11 is a prime number, so we can cancel it out or not to write it down. 12 is a composite number. 13 is a prime number, so I'm not going to write it down now. 14 is a composite number. 15 is a composite number divisible by 3 as well as 5. Then 16 composite. 17 was a prime. 18 is a composite number. 19 is a prime number. 20 a composite number. Then 21, 22, 23 is a prime number, so I'm not gonna write it down. 24 is a composite number. 26, also 25 is a composite number since it is divisible by 5. 26, then 27, then 28. That's it. So these are the composite numbers. So let me just erase the extra prime numbers. This one, this one. Okay. So now all these numbers written are the composite numbers which are greater than 4 but less than 30. So that is the answer to part A. Okay. Now part B. Try to write each composite number on your list as a sum of two prime numbers. For example, 6 can be written as 3 plus 3. 8 can be written as 3 plus 5. Okay. In the same way, mm, 6 we are done with that. 8 we are already done with that. 9. To write it down, we can have either 9 equals to 3 plus 3 or we can write it down as 2 plus 7. Both are prime numbers. Then 10, it can be written as 5 plus 5. 12, it can be written as 5 plus 7. 14 can be written as 3 plus 11. Okay, then 15. It can easily be written as 2 plus 13. Both are prime numbers. 16 can be written as 5 plus 11. Uh, then 18. It can be written as the sum of 5 and 13. Then 20. It can be written as the sum of 3 and 17. 21. the sum of 2 and 19, then 22. It can be written as the sum of 5 and 17, then 24. We can have, for example, 5 and 19, or we can also write 7 plus 17. That is also uh, the bifurcation of 24, written as the sum of these two prime numbers, 7 and 17. Okay, then we can have 25. We can have like the sum of 2 and 23. Both are prime numbers. Then for 26, we can have, for example, the sum of uh, 3 and 23, then 27. For 27, if you see, you add 3 and 24, but this is not a prime number. You add 2 and 25, this is not a prime number. You add mm, 5 and 22, this is not a prime number. You add 7 and 20, it is not a prime number. So we can deduce that we cannot write 27 as a sum of two prime numbers. So you can write it down that not possible for this to write down 27 as a sum of prime numbers. And finally 28. Can we figure out something? 23 and 5. Yes. So that's it. So that is how it is to be done. We have written uh, these numbers, these composite numbers, as a sum of two prime numbers. So that was question number 3. Then it is question number 4. Two primes are Twin primes are pairs of prime numbers that differ by 2. List the twin prime pairs up to 100. Like differ by 2. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, then 37, 41, 43, so on. We can see that 2 and 3 are not twin primes, but 3 and 5 are twin primes. Also 5 and 7 are twin primes. So 7 and 11 are not twin primes, but 11 and 13 are twin primes. 13 and 17 are not twin primes, but 17 and 19 are. Similarly, 19 and 23 are not, 23 and 29 are not, uh, 29 and 37 are not, and so on. So let me list them: 3 and 5, 5 and 7, 11 and 13, 17 and 19, 29 and 31. Similarly, we can have 41 and 43. Then, after this 43, we are going to have 59 and 61 as the twin primes. And then it is actually 71 and 73. After this, we won't be able to find any twin primes. So all of these are the twin primes. And that is the answer to question number 4. Okay. Question number 5 now. Is 149 a prime number? Explain how you decided. Okay. Uh, if you see the square root of 149, that is 12.2. So square root of 149, that is 12.2. What we need to do is that you divide 149 by 2. It is, since it is an odd number, so that it would leave uh, 1 as a remainder. Then for divisibility by 3, 9 plus 1, 10, and then 4, 14. The sum of digits is 14. So it is not divisible by 3 as well. Then divisible, to check its divisibility by 4. Last two digits 4 and 9. These are not divisible by 4. So that means it is not divisible by 4. For divisibility by 5, uh, its unit place should be containing either a 0 or a 5. Since it is not the case, that means it is not divisible by 5. For divisibility by 6, we need to see that since it was not divisible by 2, so